welcome to today's NASA social briefing for SpaceX's Demo-1 mission launch. I'm your host, McManus Woodend, and thank you all for joining us for this very historic launch. So far, everything is looking on target for a launch on May 2nd. That would be late Saturday morning at 2:48 a.m. So for those of you at home, you might want to wake up a little bit earlier than usual. But for those of you having a wonderful Friday evening, this will be a perfect nightcap for you. So right now, it will be launching from the historic Pad 39A, which is definitely an amazing place to see a launch here at Kennedy Space Center in beautiful, beautiful Florida. Now, Demo Mission 1 is the first test flight for SpaceX's Crew Dragon. Now, why that's historic? We've got this will be the first time that a commercially built and operated a launch vehicle for astronauts specifically will go to the International Space Station. Now, during the broadcast, if you're watching at home and you have any burning questions, head on over to Twitter and use the hashtag AskNASA to ask our wonderful NASA and SpaceX panelists that we have arranged for you today. So without further ado, I'd like to first bring up Carol Scott, who is the Deputy Manager of NASA's Commercial Crew Program Launch Vehicle Office. Carol.
Hi. Good morning, everybody. How's everybody doing? All right. Hey, I just want to welcome you to Kennedy Space Center and welcome you to the Neil Armstrong Operations and Checkout Building. Whether you realize it or not, there is a tremendous amount of history in this building. So, you know, the Apollo astronauts, they would stay here in the crew quarters, which is still here, right behind you, up there in this back building here. The shuttle, for shuttle missions, we held our flight readiness reviews in this room. I was in here many times with those readiness reviews. And then now we've got the commercial crew program getting ready to go launch. And it's exciting. It's exciting to be commercial crew. And then I look very forward here to having you guys and hosting you guys here. I know I heard one of the questions was asking about some of the patches or the logos up here on the wall. Those are all the missions from the Launch Services Program. And so there's also some CRS missions here that are also in the back wall there. But anyway, so my job is to make sure that the launch vehicles for the commercial crew program, there's the SpaceX Falcon 9, and then with Boeing, the Atlas V, that these rockets are certified so that they can go take our crew up to the International Space Station. And while that's really cool for NASA and it's really cool here for SpaceX and our providers, it's really cool for you because this is the first step to getting humans into space, right? So eventually, you know, the vision is so that one day we can all go buy a ticket, you know, on a rocket, just like you buy a ticket on an airline today. And that's where we want to go. So this first step, super, super exciting. Can I go ahead and open it up for questions?
Yeah, by all means.
Okay, so I was going to let you guys, because I'll be able to answer a whole lot more for you.
And we have mics that will be brought to you, so just wait to ask your question until we get everything. We've got one in the front over here. Sorry, Wendy.
It might be faster if I take mine to you. How about this? Let's do it together.
All right, let's do this.
Perfect.
Hi, I'm Joan. Hi, nice to meet you.
Nice to meet you, Joan.
I don't know why I'm the very first question because it's actually a very dumb question, but you said that we can hopefully go into space by just buying an airplane ticket. How much would that cost?
You know, that's a really, really good, tricky question, and that will be up to, you know, the provider and you to go negotiate that. I know right now, I think that cost for tourists to go up is in around the 40 million, you know, and so I know I don't quite exactly have enough in my bank to write that check just yet. So that's why we got to keep working on it and get the costs down so that it will come there. If you remember, you know, early on when we had airplanes and we had people flying on planes, you know, that was pretty much for the, you know, the wealthy and rich when it first started, like nearly, you know, 100 years ago. So it takes a while before, you know, it gets down to where we can go do it. But anyway, we want it really soon, right? So we want Benji to be able to get the cost down really, really soon. All right, how about next question?
Got one right on over here.
What's the procedure like as far as before the astronauts go up to like the ISS to make sure they're not going to bring the flu or something like that? How long are they separated from everybody else? And
All right, so how long are they quarantined and all? So I think in this program, is it 14 days? Okay, I was trying to go with 10 days, but and I'll tell you what, how about I'll let Steve Payne answer that a little bit more on that one. But they do go into an isolation period, right? Because you don't want to go and take any kind of earth germs up to the space station. So.
And a question in the back?
Hi. So what decisions or factors go into the decision to launch at 2:49 a.m. on a Saturday morning opposed to a better time?
So let's talk a little, that is like awesome. So there are lots of decision points along the way, right? So one of the first decisions that the mission support team and the launch team is going to go make is, number one, is it okay to go put this densified liquid oxygen and the RP1 fuel into the rocket, right? So we want to know, is it okay to even go tank the rocket? And so that's kind of one of the first kind of keys. And that's usually based on weather, all the problems have been resolved, the team is all ready, space station is ready for us to come up there. And so that'll be one of the first gates. And then once they get through that, then you're just working to see if there's any kind of anomalies that happen during your loading procedures. And as long as there's not any anomalies, then you are go.
Yes, we got one right. Yeah, just want to. Sorry. Thanks, Carol.
So I'm curious, how far ahead of time do you plan an exact date and time for the launch? How far do you have like a concrete time to work with?
Okay, so rockets are tricky, and trying to have a concrete launch date like an airplane has for flying out the runways really is a little tricky right now. And so what we do is we have these work to dates, and then we get into that mode, and then as we get about a month out, then we really start solidifying what the launch date is. We have a flight readiness review that's about 2 weeks out from the actual target date, and as long as we get past the flight readiness review, then we establish a date and time, and that's where it becomes truly concrete.
We'll take one over on this side. Gentleman right here.
How you doing? So I kind of have a two-parter. The first one's quick. How long in the future can we kind of look forward to like going into space like we were talking about? And the second one is, I'm a psych major, so can you kind of talk about like what type the like psych evaluations like the astronauts has to go through for the process of going into space?
Oh, that's going to be really, really interesting. Okay, so to answer your question about how long in the future, I think it depends on how long in the future that your bank account can match what it costs to get in there, okay? So I'm not real sure how to tell you if that's, 10 years or 20 years or anything, but, and then we have to see all the technical revolutions that come through to get the cost of launch down. So I know that may not be the best answer you're looking for, but that's about where I am right now on it. All right, and then all the psychology stuff, I know that they do go through, evaluations. There's a lot that goes into, to me, which is kind of more interesting than the evals for station, or the evaluation for what it takes to go to Mars. And, living in a confined space for 18 months or 3 years, with these small teams. So I know there's quite a bit that's written, about that. They, it takes a special type of, not only the personality of the person, but it's the team, right? This is where you're going to go look at a team of folks and how does this team collectively match up to be able to go do a mission like Mars or, getting up to station. Our crew is up there for 6 months at a time, and so you got to make sure you can work with them, live with them, and everybody's got to be able to respect each other. And so, they spend time on Earth here being able to go do that so that when they're up there, they're ready for it. Okay?
Yes, right there.
Oh.
I'll bring the mic. Thanks.
Hi, so my question is, if everything checks out with this test mission, when can we expect to launch humans in space again? When is the first human space flight going to be?
There you go.
So the speaker right after me is going to talk quite a bit about that. All right, since he is the one, the SpaceX representative, Benji Reed here. But our anticipation is Well, I'll let you answer that question, Benji, because to be honest with you, I'm not sure on the launch date on what I'm thinking of. But as long as, so what's going to happen is they're going to have this mission. We're going to be doing a lot of testing through this mission for all the human systems. And then it's going to, come back down. They're going to go do post-flight assessments. Right after the rocket launches, there'll be some quick looks on the F9. And then after it returns, the Dragon returns to Earth, then there's going to be quick looks and inspections done for probably a couple of weeks on how the capsule, operated while I was up there, and then also through the recovery mission. And then based on whatever anomalies come out and, that we have to go fix, that's one of the super cool things about a flight test is you're working out all those issues and all. So if something happens, that's good. We found out. We want to go, move forward with it. And once we get those ready and they get the vehicle turned around, then we'll be ready for the crew mission. There is, having the humans, especially the first time, there's some work that still has to go, be done. And I'll let Benji talk about that.
Yes.
So going back to launch operations, because of course, I still love you being further downrange than a normal CRS mission. How does the launch trajectory and profile compare to a normal resupply mission?
That's a great question for Benji Reed. You guys are knocking me out of the park here. So go, yeah, sorry about that. I'm going to let him answer that one too.
Yes, the gentleman in the white meatball hat.
Hi, I'm Jesse Gant from Harrisburg, Pennsylvania, and we have a question from a live viewer, Mariah Coretta from Boiling Springs, Pennsylvania. Two-part question. Over the last several decades, NASA has led to discover things that were once thought impossible. What's next in the impossible, or what is the next impossible mission on the horizon? And then the next question is, how can we, as a general public, help reinvigorate support behind our country's space program?
All right, those are some really good questions there. So how about instead of what's the next impossible, the next really challenging mission, for NASA is, one is not just getting to the moon, right, and being able to sustain a type of, sustain humans on the moon there, but it's getting to Mars, right? And so I know NASA, we're looking at going back to the moon. I know there's lots of interest in getting to Mars, and so I would say that probably the next focus will be, after the moon, will be Mars. And then, I'm sorry, the second part was, how to get people reinvigorated into space. I think as soon as we are, doing launches just like we're doing here, and we actually have crew with people on them, that's going to get lots and lots of interest, back into space. And so that's exactly why you guys are here, especially the teachers, the ones of you that are teachers. Thank God you chose that profession. I really appreciate that because it's you're influencing the youth that's coming up. So thank you, thank you, thank you. And it's through you that helps to get the interest to keep the space program invigorated here too.
And we have time for one last question. So if there's anyone on this side of the room, all right.
I'm glad that you said that because my question is goofy. I teach 7th graders.
Uh-huh.
In an attempt to explain where I was going, I said that this was a little bit like Uber Eats, but for space. But the kids wanted to know, when we say resupply, what actually are they getting resupplied with?
Oh, so that's a good question too. So, I think of this as, I hadn't really thought of it as Uber Eats. That's an interesting one. I always think of it, kind of like the rental car kind of thing. So, where you're hopping in and you're going on to a station there. So, but as far as resupply, those are just like you're saying, there's food, there's clothes, there's things that have to go and support the different science missions that are going on to ISS. There's new missions, new science experiments, that are coming up. Results are coming back down. So there's a lot of stuff just with the basic science that's going on the ISS that will come, back with part of the capsule and all. Well, yes. Well, they get new underwear, right? They get to have new underwear, right? And so there's, resupplies of. It's just like when you're on an extended vacation, you got to have resupply of everything. So, yep. All right. So,
Thank you very much, Carol.
All right.
Yeah. And now we'd like to bring up Benji Reed, who is the Director of Crew Mission Management for SpaceX. Benji? Great. Oh, wait, you've already got one.
I got one.
All right, perfect. I'll hold on to this one.
All right, hello. It's great to be here. It's a real honor. I love the opportunity to come here to NASA and Kennedy Space Center, and also to hang out with all of you guys. I think that getting the word out and getting excited about space. We asked some questions earlier about how do we keep motivation up for space. It's really important. When I was an undergraduate, I actually worked on that mission that's right up there. It says FUSE, Far Ultraviolet Spectrographic Explorer, and that's the kind of things that you should do. And my son's a 7th grader. So I saw the 7th grade teacher there. And so, yeah, keeping that out there, and it's a huge part of what we're doing here at SpaceX. So I think I've got some slides that we're going to bring up here in a second. So some of this was already mentioned. This is an historic mission for SpaceX, for NASA, for the nation, for the world. As you know, Dragon was the first vehicle ever to be built by a non-government entity to be sent up into orbit and brought home. That's Dragon-1. It's hanging up in our facility right now. And then this will be the first time we've built, a commercial entity has built a vehicle to carry humans to space. And of course, Dragon was designed from the beginning to carry humans into space. And this is an awesome shot. You can see the crew access arm where the astronauts are going to walk out to get onto their ride. There's the ride, there's Dragon. You can see the Dragon trunk, and then below that is the Falcon 9 vehicle. And this is all at historic Pad 39A, home of Apollo, home of the space shuttle, all these great things. I'm going to actually bring up here in a second now a video that our team's put together, and we'll just kind of let that play, and then we'll talk about that some more. Awesome. Woo! I love that. That's a brand new video I'm super excited about. You saw a lot of things in there. There's a lot of testing going on, testing of our Super Dracos, testing of all of the thermal vacuum testing that we do, and parachute testing. Huge amount of what we do is making sure that Dragon is going to be safe to carry humans. As I mentioned, it was designed from the beginning to carry humans, and our #1 goal is to send those astronauts up and bring them home safely. It's got some good stats here, some great facts about what's going on with Dragon. About 27 feet tall. Dragon was designed to carry up to 7 astronauts or 7 passengers. And on the configuration that we'll be flying for NASA, that will have 4 astronauts and about 200 pounds of cargo. And there was the question about Uber Eats, and I think that's a great example. Dragon has flown 16 times to the space station and back, Dragon-1. And so that's the cargo Dragon, and that is sort of like Uber Eats. That's where you're like ordering up all the stuff that you're bringing up, the food and the clothes, but also a ton of science, right? Space station is a national lab. It's a national laboratory and an international partnership as a science laboratory. So a huge amount of science that gets done up on station. And then to do that work, we need a staff that keeps the station running to actually run the experiments and do things. And of course, those are our astronauts and also astronauts from all around the world. And so they need a ride as well. And that kind of goes to what Carol was saying about getting a ride and getting your car to head up there. And that's what this Dragon is going to do. So Dragon is going to carry 4 crew members to do a rotational mission, which will last about 6 months for each of those operational missions. And then they come home in the same vehicle. You can kind of see, I'll just give a really quick, point out a couple of things on this graphic while we have it up. You can see that this Dragon has windows. The cargo vehicle doesn't really need windows, although the first few of them did, fun fact. Another thing that this Dragon has, kind of those gray spots on the side, those are the Super Draco engines. We've added those to help provide a launch escape system for Dragon. So just in case, in the very unlikely chance that you need to get away from the rocket really fast, you can do that. And so the Dragon will pop off and bring the astronauts down to the water safely. That's kind of a lot of the things that are different. Other than that, we've based this vehicle on the Dragon that's flown, like I've said, 16 times to station and back. All right, let's go to the next slide. Great. This is some awesome shots of the interior of Dragon. You can see there's the 4 seats. This is the NASA configuration that we'll have. Below those seats is some area for cargo, some cargo pallets. When we take up cargo, it's important that we have cargo that, like I mentioned, kind of like stuff that you put into bags, but also there's a lot of science. There's powered lockers that carry up various science that needs to be kept at a certain temperature, other things like that, and so we carry those up. We allow, and of course we bring all of that back home as well, so that the space station scientists and everybody who support that can get quick access to that cargo. And very importantly, bring the astronauts back, bring the crew back and get access to them safely as well. This gives you a sense of the trajectory of what's going to happen with the launch vehicle and Dragon. It's important to note that while we've been flying Dragon and we've been flying it on the Falcon 9 and using our launch systems all of this time and getting a huge amount of experience on that, one of the things about this program that's a little bit different is that we need to certify the entire system for flying humans. We've always built all of our systems at SpaceX to a very high reliability. We expect that all of our fleet across the Dragons, across the Falcon, all of our ground systems are managed and maintained at a very high reliability and high safety margin. However, working with NASA, we actually have to certify all of that work as part of the commercial crew program. And so this is a big deal for us because it means that we got to certify the Falcon, which now has 70 launches, the Falcon family. Yeah, super exciting. 70 launches and a ton of homecomings and even a lot more reflights as well after that. But we get to certify that whole system now for flying humans as well. And so that's important. And of course, like on all of our missions, whenever we can, we always try to bring the rocket home. So you can kind of get a sense if that's what's going to happen here. Dragon will be on top of Falcon. Falcon will go up. Not long after launch, we'll separate the stages. The second stage will go on to orbit with the Dragon on top. Then the first stage will turn back around and come home. As mentioned by one of the audience members, we're going to come back home on the drone ship, Of Course I Still Love You. It's going to be very exciting to see. Okay, next slide. This is a great video kind of showing this. This is actually a cargo launch, a real cargo launch. You can see the Dragon on top there. And then that's that going up, heading up to space. Then that first and second stage separation, and then first stage turns around and comes back home and lands on a drone ship right there. Pretty cool. Awesome. Okay, we can go to the next slide. Okay, finally now, of course, the big goal of all of this is to get those astronauts up to station so that they can do their work up there. And so this is an image of what it'll look like when Crew Dragon comes to station and gets ready to dock. And it's an interesting thing, right, because the cargo vehicles and other autonomous vehicles like the cargo vehicles are berthed, which means they kind of come up, they get really close to station, and the robot arm, the Canada arm, reaches out and brings them in. But for crewed vehicles, vehicles with crew and with astronauts on board, you actually want to be able to dock because it gives the astronauts and crew more control, more safety, and also when they're on station, they can all leave if they need to, or they can get off if they need to, without having to worry about the robot arm. So what that means is that the Crew Dragon is going to come up and actually dock itself. It's going to come in and dock right in there. And you can see our docking system on the front. The nose cone there is opened up. The docking system is ready to go, and it mates with the docking system, the docking port, on the other side of station. We're going to be on the Harmony module of station on the Node 2 forward. And kind of a cool thing is that these docking ports on station are devices that we've brought up on the Cargo Dragon. So those go in the trunk of the Cargo Dragon, get brought up to station, and then get installed by the astronauts, and then we get to go. So we kind of had to like send the door up, right, to get to station, and then we got to go and use that door. It's kind of cool. I think that's really it for what I have, and we can open it up for any questions that you have.
We'll start with the gentleman over there. Yes, please.
Hi. It is so exciting to be in a room with somebody from SpaceX as well as all these NASA people. It's fantastic. Two real quick questions. One, there is an aesthetic to the SpaceX craft and every piece of equipment that is gorgeous and is different, and that's not accidental. Somebody designed it. I'm just curious, are there Tesla designers or somebody working on like the resemblance to, say, 2001, A Space Odyssey is uncanny. I'm not kidding. Like, it's beautiful. Secondly, so much of this technology is automated and in a way sort of like self-flying rocket in a way. Is that part of the plan? Will there be self-flying rockets? I mean, this is longer down the road, and in that vein, are the guys who are going to fly on the Crew Dragon next? What will they? Is there anything they're going to be doing that's different than what, or are they just along for the ride in a way?
Sure, understood. Those are great questions. So first of all, about the aesthetic. So first and foremost, everything that we design for at SpaceX is for the mission. It's for flight reliability. It's for making sure we're going to be successful in the mission and the safety. In this case, the safety of the crew, both on the Dragon and the crew on station. But it's also really cool to be inspiring, right? Because ultimately we have to inspire the opening up of the space age, right? We've been kind of getting there, and now it's really time. We talked about being able to send people and everybody being able to go up and buy a ticket to space, work in space, live in space, make life multi-planetary, right? This is SpaceX's mission, and I think it's all of our mission in many ways. And to do that, you also have to be inspired and excited. And so that aesthetic is important. In terms of the autonomous nature of the vehicles, in fact, launch vehicles right now, rockets, are pretty autonomous. There's just so much going on, it's going so fast, it'd be very, very hard for a human to control it from the ground. So launch vehicles already are going up and doing their thing, basically running on very well-programmed computers with lots of checks and lots of methods of making sure that they're tolerant against faults. You'll hear that a lot in NASA terms and SpaceX terms, there's a lot of fault tolerance. How do we make sure that it's not going to have a failure? So we already do that. This vehicle, the Crew Dragon, just like the Cargo Dragon, is a fully autonomous vehicle. This mission coming up, Demo-1, it's going to go to station and come back. There'll be ground controllers who are also working it. For the crew on board, when it comes time for them to fly, they'll have the opportunity, of course, to control aspects of the vehicle, and in certain situations, if there's an emergency, they have a lot of control there as well. The crew has been working with us, it's important to note, all of these years that we've been developing Crew Dragon. And so they've been getting their input and working back and forth. You know, they're really part of the team, and they work with all of our designers. And so they get to help put that input and make sure that they're going to be comfortable and excited to ride on the Dragon.
All right, we have time for, unfortunately, one more question, so we'll go ahead and the gentleman here in the first row.
I know we're all here and excited about DM1, but my burning question has to do with the in-flight abort test. When you do that, are you guys going to use the flight termination system, or just have the Dragon abort straight off the booster? And if that's the case, is there any hope for recovery? Will there be legs, grid fins on the booster?
Sure, okay, that's a great question. So as you guys probably know, a number of years ago now, I think it was 2015, we did our pad abort test, which was really important to do that. We did that a few years ago. We've learned a ton from that we've already put into the vehicle. So we get to do it again, which is really important. We get to do another abort test before we send people up, and that'll be on a rocket, on a Falcon. Yeah, we're going to see, we'll see which one we're going to put it on, but we'll put it on the rocket, launch it, get it to the right test conditions, and then escape Dragon from the rocket and bring Dragon home to prove out that system completely. Our goal is always to bring hardware home, right? Because when you bring hardware home, you get to learn from it. And that goes right to the heart of reliability, right? You get to understand it, you get to investigate it and inspect it and do all that kind of good stuff. So we always want to do that, and we want to bring, so we'd like to try to bring that rocket back home, but the most important part of that test is that we're going to do the Dragon and get the Dragon aboard and make sure we understand that before we go fly humans.
Excellent. Thank you so much, Benji. And our next presenter will be James Bean, who is the launch vehicle lead engineer for NASA's Commercial Crew Program. Let's give it up for James.
Good morning. It's amazing how the crowd looks bigger from the front than when you're behind it. Welcome to the Operations and Checkout Building, or as I like to call it, my office. So I sit right upstairs here with the Commercial Crew Program. As I mentioned, I'm the lead engineer for the Boeing launch vehicle, so I follow the Atlas V. I work directly for the chief engineer. So his task for me is to lead the engineering team, to do all the many reviews, to do all the assessments, to do a lot of the boring paperwork, to ask all the right questions, to try to get to work with the program so that we can be ready and prepared and comfortable for flying a commercial crew mission from the top of an Atlas V launch vehicle. So when we say launch vehicle, I'm not sure if we had a couple of pictures, but when we talk about the launch vehicle is basically everything starting at sitting on the pad, going right up to the top to where the spacecraft sits on it. So that's the launch vehicle. When it's fully loaded, that's an Atlas V is 1.2 million pounds. So I playfully like to remind our spacecraft team that when it's sitting on the pad, about 98% of that vehicle is launch vehicle, by weight, of course. But one of the questions is what does launch vehicle do? Or as far as what is NASA doing with the launch vehicle to certify it? Well, what we're covering is, we're doing a lot of the boring paperwork, but we're gonna look at what does the vendor do, or what does our partner do? Both partners, in this case, both Boeing and SpaceX, bid launch vehicles that are already existing operational rockets. So they didn't design them from scratch, and that's perfectly in line with the commercial aspect of commercial crew. If you have an existing operating launch vehicle, clearly you can do that a lot more cheaply than you could do a brand new design. So NASA was completely on board with that, and so rather than expect all these new analyses and all numbers crunching and so on, they shared with us, here's what we did do. And so working with our partner on what they did do and working through that it meets the intent of what NASA wants to see. So we're working through a lot of that paperwork. We're also working, there we go, you got a good video so you can see this, in this case, an Atlas V. Gotta love that. Someone playfully asked earlier, what's your favorite color? Mine's the bright white that comes out of the back end of a rocket, so. Of course, here's a Falcon 9 launch as well. And so maybe I should caveat my answer. I also love the white that comes out of the front end of a landing Falcon 9 booster. So, but then it also questions, what's different for NASA? What is NASA doing with human spaceflight? What's different as opposed to an expendable vehicle? The first and most obvious difference is we have an abort system. Unmanned systems don't need the abort system. We work with the partners already work extensively to minimize any issues, any concerns, any likelihood of a problem. And that's great, but we also say with humans on it, we have to have the ability to get them away as well. So putting an abort system on a rocket and all the complications that go along with it to make sure that in the very unlikely situation of a problem, we can pull the crew away and get them safely back on the ground so that we can try this on another day. So that's one of the biggest items. And the other is also an approach that NASA's learned through problems in the past where rather than looking at it from the bottom up of how do you design this to make sure it really, really works really well. Hey. Now, was that the hot fire from? Okay, so that was a Falcon 9 hot fire right there. That's in preparation for the Demo-1 launch here on Saturday morning. Back to where I was, one of the approaches that NASA's bringing to this that's a little bit different is learning from our past history, rather than looking from the bottom up, make sure it really, really works. Let's look from the top down and all the credible ways this could have a problem, and what do we do to prevent that, or what do we do to minimize that? And so it's taking that top-down view and doing all the extra hard work and doing the paperwork that says, here's what we do, or here's how this is going to not happen, and working through that. And so we're going through it both directions to really make sure this is going to be a reliable and safe vehicle to fly. So with that said, I'm open if we have a little bit of time for questions.
Yeah, by all means.
Yes, sir.
So as far as for this launch, how close is it going to be to the actual crew? And as far as like the nitrogen oxide load on there, like oxygen, the carbon CO2 scrubbers and all that,
As far as DM-1 goes, I'm going to look to Carol, but this is as close as possible. The same, okay, absolutely the same. And clearly, you want it to be the same or as close to the same as possible because you don't want changes when you put crew on first. You don't want to tell the crew that anything's different. We want to say, we've flown this before, it went well. So.
Yes, right there in the front.
So I understand this is probably a ballpark figure, but just how many things need to go right in sequence for us to be go on Saturday? Come on, I know you got a ballpark. It's got to be
thousands. At least thousands, but it's, a launch vehicle is going to have hundreds of thousands of parts on it, but between things working right and all the checkouts, that's why computers do this for us, because we couldn't possibly go through all this many things. Because all that cryogenic fuel would have boiled out till we finally figured out, hey, it's good. So yeah, we have to have the computers go through, but yeah, it's thousands upon thousands, and so that's why we have to have the computers do these for us.
Yes, the gentleman here in the front.
So I don't think the SpaceX person hit on the question about the launch profiles, if they're any different. But also the solar panels on the Dragon are completely exposed during launch. How will they be protected?
I think I'm going to hand this over to Carol as the launch vehicle manager. You might know a little better.
All right, so let's go back to your first question. It was
how the trajectories will be different other than versus a CRS mission.
Okay, so let me stand up. Sorry, you stay here. I'll give this back to you. All right, so the trajectory is not going to be any different than what because we're going. Just like with CRS, we're going to the space station. Of course, the space station is in a different position, right? So there are some trajectory differences, but it's all based on, where you go meet up with space station. So all that'll still be the same, okay? And then the protection for the solar arrays, a lot of the debris is coming, is on, I'm gonna say is on the way down. Your solar arrays are more on the top. And so I don't know, Kelly, if you got any more you want to add to that? You're the one.
Yeah, solar arrays at the top, so you're not going to get the debris coming from the launch vehicle below. And also there's time limits on what those solar arrays can be out in the weather elements while on pad. So that's kind of what's the limiting factor on those.
All right.
Will that affect the launch windows too? Instantaneous or not?
Not as far as instantaneous. What does instantaneous is the orbital trajectory to get to station to catch up with it. The solar arrays come into play if it's outside for extended periods of time.
Okay, thank you.
And these are one-time use, correct? These solar panels on the trunk. Should make not quite sure. So, but okay, yes. And
that was a 3-panelist answer, so that's got to be some sort of record. And we have a question in the back.
Yes, I'm going to reiterate my question. So when can we expect humans to be able to fly? If everything goes right on Saturday morning, will there be another test flight? And when can we expect the first crewed flight?
We're going to follow our partners' lead on this, SpaceX and Boeing. Current plan is later this year, though. So if things go well, things go correctly, we could be, it's August, no earlier than August. They're tentative dates, but as opposed to other NASA missions where we were always very upfront and say, here's where our target is, these missions are actually owned and operated by our partners, so we follow them. So our SpaceX and Boeing partners will set these dates and we'll follow them. So that's why we're a little less certain on the dates, but we're going to follow their lead in this case.
And we have a question in the back.
So this is one of my students' questions, which is there a possibility that the Dragon crew capsule could be modified to land on the moon? And if so, what would be the benefit of going back for the astronauts and space in general?
I honestly, I wouldn't have the answer for you as far as the Dragon goes. We've seen SpaceX has done great, amazing things, so I wouldn't be the slightest bit surprised if they could. So I'll step aside from that question. But going back to the moon is something that our NASA administrators has announced that is what we want to do. And going back to the moon is a stepping stone and going to Mars. If we want to go many, many, many millions of miles away and spend 8 months getting somewhere, let's try and cut our teeth on a place that's 2 days away. So spending time there, learning to work there in a relatively inhospitable environment. So let's do that there, and let's develop our technologies there, and then let's take that leap to go over to Mars.
And we have a question in the back.
Hi. So could you briefly speak to the primary differences between the Atlas V and the SpaceX Crew Dragon programs? And do you guys have like a healthy dose of competition? Do you get along pretty well between the two?
Coming from the NASA side, we love them all. They're very interesting. They're very different approaches. And so while I work as a lead engineer on the NASA side for the Atlas V, I have a partner who also works on the Falcon 9 side. It's a very different pace. It's a very different approach. And there's pros and cons on both sides, but it's just different approaches. And we follow our partners and what they do. And it's all a matter of making sure that what gets built and what gets put on that launch pad is ready to go, that we've got the insight to say that, yes, that's absolutely what we want, so we're ready to go. But as you've all seen, there is healthy competition between our two partners, and it's very interesting to see. It's the capitalist approach. Let's have competition.
Question in the back. We have a mic coming for you.
Not sure if I should be asking you this or not, but I'm curious, how hands-on is Elon Musk? I mean, how involved does he come to the launches usually?
I'm going to hand this to Carol. I know it's a little bit better. Works both launch vehicles.
So if we see any Benji or any of the SpaceX guys out there, but I will tell you, I think Elon is very hands-on with this rocket. I know meetings that I've had with their chief engineers and the chief Dragon designer and the chief F9 designers. Elon, they report to Elon several times a week. He is there at SpaceX at least 3 days a week. And so he is very, very hands-on. I don't know personally if he is here or if he's at Hawthorne, for the launch, because it's just a day before it gets to space station. And I know he wants to be there to go and watch the docking of it. But he has definitely been here for launches. And so, yeah, he is very, very hands-on.
We have time for one last question in the back.
Hey, thanks. So this question is from Twitter. Twitter user Dolo Stone asks, what type of sensors are on board? And this mission, will it be going all the way to the ISS? Will it be stocked with supplies? And if you guys need a guinea pig, he wants to volunteer.
Well, if we need any guinea pigs, we've got the astronaut corps. So we say that playfully, but yes, going to ISS, absolutely, that's the target. This will go all the way to this Crew Dragon will go all the way to the space station. We'll come within, we call it the ellipse, that's getting real close to the space station. Everything lines up correctly. Get the go-ahead to go up there and mate with the space station. Again, that's making sure everything stays safe. We've got crew on the station right now. We don't want something coming close that looks, that's got any problems with it. So, it could be waved off if there was a problem. We surely don't expect that. But yeah, go all the way to the space station. Make sure I hit on all your points there, though. Could you repeat the first half of the question?
The question was, will there be supplies on it? I think you answered that. Will it be going to the space station? It is. And
sensors.
And the sensors, yes.
Ooh, you name it, it's on there. But yes, as the earlier question was, how many things have to go right? All those sensors. In many, many cases, these are double and triple sensors because you just have to have the answer. So if you want to make sure you got the right propellant load on that rocket, you measure it 3 times. Because if one of them goes out, you still want to have 2 measurements. So you've got propellant load sensors, you've got accelerometers, you've got temperature gauges. I mean, you name it, it's all over, because in a regular rocket launch, you need to know all these things. On a test mission, there's even more that you need to know. So in order to get these vehicles, both a spacecraft and a launch vehicle, certified in NASA speak, you need to know a little bit more about what's on it. So in some cases, this is the first time you've done a few of these things, because you just can't test everything. So the test mission is to go out there, to operate, to go ahead and put it through its paces, to go through all the G forces that it takes going uphill to the space station. Make sure everything that you expected, that you predicted happened as it was supposed to. And inevitably, a few things will find out, hey, that saw more acceleration than I thought it was going to see. And so we work through those things. So that's going to be the work that'll happen after the uncrewed test, to make sure everything's happy. And then we do the crewed test to make sure we're right back on that have our pencil sharpened and say that operated exactly as we expected. So that's the whole purpose of these flight tests, is to make sure these things go just right.
And thank you very much, James, for all of those wonderful answers. And our next presenter is the NASA Ground Systems Lead Engineer. You got to hear a little bit from her before, so let's go ahead and bring up Kelly Maloney.
Hello, good morning, everybody. So we're all talking about the rockets in space, and I'm the ground systems lead engineer, which means I'm responsible for everything on the ground. I have to make sure that these things get off. So that means for this SpaceX mission, that's at 39A. And what that includes is once the vehicle comes here to Kennedy, it's all the ground processing. It's fueling it, it's the tower, crew access, it's the transporter erector that has all the umbilicals that gives you all the power and fuel to the rocket and the spacecraft. And the neat thing about SpaceX is that they are using one of our very historic launch pads. So 39A, so here's a good picture of the shuttle right there on the mobile launch platform and the tower there on the left. So what that tower is that's what gives us for access for crew, and as I mentioned, the fuel and electrical. It also has a history to it. That tower actually came from Apollo's mobile launcher tower. After the end of that program, that part of the tower was removed and fixed here and used for shuttle. And then, so this was used all the way up until the end of the shuttle program in 2011. And next slide. What this means is now SpaceX is leasing this pad from us, and they have built their own. So this is a good picture of them and their hangar that they put together to process their Falcon 9 vehicle and the spacecraft. And in the background, you can see the tower and rotating server structure I'm talking about that we use for the shuttle program. Here's just another good angle of that. Again, that's the pad surface and the tower and the rotating server structure as it starts to be transformed for SpaceX's use. And here's kind of the final well, they're still doing a bit of mods, but this is what is left. They're using the same tower. There's Apollo tower, shuttle tower, SpaceX tower now. So it just gives you an idea of the evolution. And that's the rocket sitting up there on the pad. So my team, we are comprised of mechanical fluids, electrical, and also command and control, and that's the software that launches rockets for all these pad systems. And most of my team have very large shuttle backgrounds, so they've done this over many launches. So we're very familiar with this pad and these pad systems. And our job is to work very closely with SpaceX and impart our knowledge on them to say, hey, we've seen this before. Here's things you need to look out for. We need to make sure that they have a successful certification of their vehicle. So with all that history on our ground team, our whole point is to help SpaceX get back to space, get crew to space. So my personal background is I started in shuttle myself, and I went over to the design world. So I've actually done a lot of design of these crew access arm and umbilical systems for one of the NASA programs, which is Space Launch Systems. And so I'm using my design knowledge plus my shuttle knowledge and imparting what I can to our two commercial partners and to help them succeed. And that is how our team works. And we're very closely involved with the team at SpaceX. We're all here local, so we're out there every day doing pad walkdowns, doing activation of their systems. Any new systems, like the new systems for crew would be that beautiful crew access arm they have. Doesn't that thing look cool? It's like something out of a sci-fi movie, but yeah, Elon likes to have everything looking top shape. And so we're just here to make sure that that's a hydraulic arm, that the hydraulics are working correctly, that they have enough capacity. Also emergency re-extend for a crew to get on and off the vehicle in case something does come up. We help them reach those goals. So I think that's all I had. So if anybody had any questions, I can try to answer.
Let's go over here in the front row.
Yeah, just a quick question. About how much does it cost to make the Crew Dragon, and about how much does the launch operation cost relatively?
I'm not sure about the Dragon. That's a SpaceX question, but it is very expensive. Otherwise, we all would be doing it, and not just the billionaires. As far as a launch campaign, I mean, that's in the millions. I don't know what the latest figure is to get a pound of payload to space now. I forget what it is. There used to be a number associated with that. I'm drawing a blank. I want to say it's a few $1,000s just to get like a pound of stuff up. It's 10,000 a pound. Okay, that's kind of what it was. I haven't adjusted for inflation for 2019 yet, but about that range, just to give you an idea. And so depending on the size of the rocket, the fuel, so I didn't touch on this too much, but the rocket here SpaceX's rocket uses liquid oxygen, and RP-1 is that's kind of a kerosene for their fuel. And to densify and get that cryogenic is very expensive to do that. Shuttle used cryogenic oxygen and cryogenic hydrogen, which is also very expensive to process. So this is not cheap to do. But I think if we get it more routine, the cost does come down, and that's the nice thing about using commercial partners. They're always finding ways to make it cheaper. So.
Gentleman in the back.
Hello. Hopefully this is a question that you can answer. What's the pros and cons of landing in the water compared to landing on land? Would that be a question for you?
I can try to answer that one. So landing on land they both have pros and cons. So land is easier to get to for recovery, but you have to be far away from any civilization, towns, because you don't want to have, if it's off by a few miles, you don't want to hit and land on someone's house. And also landing on the land is a much rougher landing. So like the Soyuz does on land. So what they do to mitigate this issue is that they actually have their seats, basically a pyro goes off and then moves the seats to adjust. So right when it hits, you don't get that big jolt to the crew. Water landing is a lot softer because, again, you're on water. It's still a pretty harsh landing because you are coming down pretty good. They all have the parachutes. And with the water landing, you run the risk. One of the cons with water landing is that if it doesn't land just right, it could tip, water, get in, and sink before the crew gets there. So that's one of the cons. But with the water landing, seeing that our Earth is mostly water, they have a large area that they can target rather than on land. Soyuz, it works out pretty good because they're out in Siberia. But if we tried to land something like that in the U.S., just too many people.
Yes, right in the front.
Do you have to deal with any wildlife interference? And if so, what do you guys do about that?
Good question. Yes, we do. The biggest thing for us is birds and bird strikes for launch. So this is a wildlife sanctuary here at Kennedy, so we have a bunch of animals, and birds is one of the big things we have. So there's a lot of things we do to mitigate that, depending on pad and depending on what the time of year. So we have watchers that make sure they've cleared. The shuttle used to have, they make sound to kind of like a high screeching noise. We used to have air cannons that would go off right before, so that would scare away any birds on the pad, because the thing is, moving at that speed, if we had a bird strike, we do run the risk of a little bit of damage. So we try to clear that ahead of time.
Gentleman here in the blue shirt.
I was just wondering if you could give like a rough estimate of the turnaround time for 39A in between launches.
So for the commercial system, I think we're trying to get to a goal of 2 launches a year. So, but however, with shuttle, we were able to do a much quicker turnaround. I want to say in a couple months. I think 2 to 3 months we could do it. Now, we had multiple shuttles to make that happen, and just as SpaceX has multiple rockets to make that happen, if pressed in that range. So I don't know SpaceX's fastest they've done it. So they're pretty quick. I almost want to. It's a couple weeks now. Okay, they're quick.
Is that time any different for switching from Falcon 9 to Falcon Heavy?
Very good question. So what SpaceX is doing to the pad now, they're trying to reduce this time. For example, hold downs. So you mentioned a Falcon Heavy. What that is it has 2 boosters instead of 1, and therefore we had to double the amount of hold downs on the ground. And so they've already modified our transporter erector, that tower that sticks up that the vehicle sits on, with those extra hold downs. So when they go to the Heavy, it's already in place, and they've also modified and put their software to handle the Heavy. So all they have to do is just switch over to a different version to get to that, to launch a Heavy. So I don't have the exact time to tell you, but they are working to shrink that so they can have more Heavy launches in between these crewed and cargo missions.
All right, we'll take one last question.
Hi, I'm Lisa Marie, and my question is about balancing cost and safety and reusability of hardware on the actual tower. What percentage approximately is reusable with umbilicals and just the structure itself?
So for the launch, all of it is meant to be reused each launch. The tower and crew arm, umbilicals. Sometimes with umbilicals you do get damage to the lines that have to be replaced every time. So we try to make the system very robust so they do last. So we do get torn up a little bit over launch, and even just being in the environment where we are, we're on the coast, so we use a lot of mitigation as far as for salt intrusion and corrosion. But the intent is to have pretty much everything on the pad side to be reusable, and except for, a few lines and things like that. And we're always, I say we because NASA does this a lot, but we're also helping SpaceX do this for their launches, and it's also Boeing ULA.
Excellent. Thank you again, Kelly, for all of your information. And our next presenter is Dave Brady with the International Space Station program. He is a scientist, and he's going to tell you a little bit about what's going on. So let's welcome Dave.
Thank you. Well, thank y'all for being here today. Y'all really inspire me. I wish everybody on the program online could have heard the pre-program introduction. So I'm going to give you my version of that because I've been with NASA for 30 years. I was with the Air Force before that. I've got a number of degrees. But one thing that kind of bonds us together is the inspiration of space. So 30 years ago, I was applying at Johnson Space Center. I was an Air Force lieutenant, and I was looking for a job, and they're moving me around to different interviews. And I'm sitting in the room with the chief flight director, the chief of the flight director office. And what that means is the person who actually runs mission control in Houston, that's the flight director. And this is the person that's in charge of all of those people that run mission control. I have no clue. I don't know what a flight director is. I'm going, this is another interview. And he looks across the table and he asks me, "Are you a space cadet?" And of course, I'm thinking, oh, this is what they always teach in those interview classes. This is one of those questions. Do you ask, what does that mean? Do you try and answer the question? So I sat there for a second. I went, what do you mean by a space cadet? And he says, someone who eats, lives, breathes space. You'd work here for free if they just gave you the job. Yes, I am a space cadet. So I know all of y'all can relate to that, and I just want to tell you that because my official title is I'm Assistant Program Scientist for the International Space Station Program. So I work for Mr. Shireman, Kirk Shireman, the head of the program, and also our chief scientist. And our job is to make sure that what we do with the space station and all its resources head towards a benefit for humanity or a benefit for exploration or new discoveries that will benefit us so that the taxpayers' dollars go into good use. And the crew commercial program is an integral part of that. And we're continuing to try and commercialize space. That's one part of it. But the other part of it, we're going to get an additional crew member to do science, which should just about double the amount of science we can do on space station. It depends on the particular time of year, but that is a huge improvement in our ability to crank out science. So we've got cargo vehicles going up that's delivering the science. The CCP vehicles will deliver about 200 pounds with the crew and bring back about 100 if I remember correctly. So I'm here to talk about the science. I'm going to start out with a 2-minute video so you can see a little bit about what's going on there, and then I'll take your questions. All right, I hope y'all enjoyed that. If you want to use that, that's called Science at 17,500 miles per hour. You can go out to YouTube and use that for your followers or whatever use you want to. It's for public domain use. So, questions? Yes, sir. Oh, I'm sorry.
No, hey, you're fine.
There's been a lot of cool stuff with some of the biomedical stuff and scary stuff with like antibiotic resistance and stuff. And I'd heard that one of the reasons they deorbited Mir was because there was like fungus and stuff growing in there behind the racks and stuff that was problematic. And is that a problem that ISS has to worry about as far as what's just the overall health of the station?
It's a very good question. I work a lot with Sarah Wallace. She's a microbiologist at Johnson Space Center. We do a lot of studies and we take wipes of all the surfaces so we can manage the environment. One of the challenges of a vehicle like that is it's all a closed environment. And there's a lot of research going on the ground and in space right now on the microbiota that's in your system. It's estimated that for every cell in your body, there's 9 cells that don't actually belong to your body because of the ecosystem. So the ecosystem that exists within your body. So the space station has its own ecosystem, and we're trying to understand that. One of the most interesting sets of experiments we're doing on that is with a piece of equipment that started out as the investigation team was the, molecular, I'm trying to remember, it's BMS, biomolecular sequencer. And it's a small device about this big or so. And you plug that into a USB port, and what it does is actually does DNA sequencing on orbit. And so Kate Rubins, who you saw in the blonde hair and the pigtails, she was the first person to sequence DNA on orbit. And then Peggy Whitson came along a little bit later. And what we're trying to do is we're trying to get from the point where we can swab a surface and immediately on orbit determine what that is. And it gives you several advantages, this system. And it's a sequence of different experiments, and I won't go into all of them. But first advantage, obviously, is to monitor the environment that your crew members are in. Second advantage, potentially for something like this, is if someone gets sick, you can determine what type of DNA-based organism that they have. Third advantage is if you go to someplace else, say Mars, and you have DNA-based life form there, you potentially have the capability to identify that as well. So that's just scratching the surface. But if you want to know more about that, look up the BEST experiment, B-E-S-T, because that's the latest version in this series of experiments. Excellent question. Thank you.
I'm sorry. The front row.
Hi, Stephanie Walker here. We saw a little bit on the video, Scott Kelly up in space for the year-end space mission. I was just wondering what would be the next big mission for our mission to Mars for the space station, if there's going to be any other big missions like that on the space station.
We do 2 things. I'll mention 2 things. Technology development is really big, and there's various things going on there, everything from 3D printing to we're doing 3D printing of recycled material. We started out just seeing if we could do 3D printing in space, and now we're moving to the point of where we're able to take the same material, put it back into the machine and reproduce some more. We're also doing some bioprinting as well as another exciting field that's coming up. So that's kind of the technology side of things that we're developing. There's many more, but in the time we have available, I just want to mention that. And the other one is we have a whole group called the Human Research Program, and they've identified a number of risks. It's about 3 dozen line items that we have to retire: radiation, isolation, understanding the microbiome of a spacecraft and of the people on board. To directly talk about what you're talking about with Scott Kelly and the 1-year mission, we're also Human Research Program is also tentatively planning and looking for opportunities to fly additional 1-year missions. One of the advantages we had with the Kelly brothers is they were twins, and we probably won't have that opportunity again because we haven't identified any twins as astronauts. But we will try and follow on because, as probably all y'all know in science, the more samples you can get, then the better your statistical confidence is in your data. So that's, hopefully I gave you at least a few answers, even if there's a whole lot more about that iceberg below the surface. Good question.
Yes.
Hi, Vernon Gutenschwager here. I'm curious, you mentioned how adding 1 extra crew member on this was going to give you potentially double the amount of testing capability and experiments. How much does the average crew member work while on board? Like, do they have a set day, or is it kind of just like all day long? Very curious about that.
Yeah, I worked in mission control about 24 years, and I can't remember the exact number, but I'll tell you that when the crew is actively doing science, a 40 or 50 hour week total is not unusual. Because when I came out here, I was talking to public affairs, and I said, hey, what's NASA saying about this double number thing? Because someone's going to ask, well, what is that number? And I'm like going, so we're looking at, to kind of answer your question from a standpoint of hours, because I don't want to duck it and say just double, we're hoping to go from the 40 to 50 hour range on a regular basis to the 80 to 90 hour range on a regular basis. And then if you divide that on crew members, you could get a number of hours per day. But remember, the reason we're getting such a big increase with the additional crew member is once you have a certain number of crew members taking care of the vehicle and the coming and going of cargo vehicle and the coming and going of the crewed vehicles and all that, then everything above and beyond that potentially is just doing utilization, just doing science, just doing technology development. Did I answer your question? Okay.
And we have a question in the back.
Hi. Okay. So I was thinking, when is NASA going to the moon to do a vote? Like, when we're going to the moon, are we going there to set up a lunar base? Like, so we're going to stay there and set up a lunar base. But I was thinking, what was going through my mind was, do we deploy robots, or will there be astronauts first to use this type of technology?
It's a very good question. I used to work in a lab, and I worked for a physicist, and he would always say, when you're an engineering manager, you always want to know what's your schedule. Now, what am I going to do, when am I going to do, and how much it's going to cost. He says, but when you're doing science, usually all you can do is say, what's my next question to answer? So I'm going to answer your question sort of in that way. Right now in Space Station, we have various types of robotics. Actually, within the whole agency, we have various types of robotics that we're developing alongside our human capabilities. Robonaut is a very popular example. It's a humanoid robot that we developed in collaboration with industry as well. So I think you'll continue to see those types of things going on. The robot arm that exists on the station, I should say the robot arms that exist on the station, because there's one big arm that you usually see, but for example, the Japanese have their own arm that they use for their external pallet as well. We also have Dexter, which is a smaller arm. An interesting side note of all that is that robotics technology, which was necessary for building the space station, has come home to improve robotic surgery. There are surgeries that couldn't be done or were very high risk before simply because we didn't have the precision, for example, brain tumors. And we can do that now because of the technology that is being used on board the space station every single day. So getting back to your question, the goal is to use the space station to develop technology, to understand our risks and understand how to manage them, because once you go beyond the Van Allen radiation belts around Earth, then you're in deep space radiation and you're subjected to a much more intense radiation dose there. To do that, we will use robots, we will use humans, we will use elements that we've learned from space station, we will use commercial industry, and I think recently they talked about having commercial industry. There was a a press release on having commercial industry propose a lunar lander that we could use from what we are calling now the Gateway, which is essentially a deep space outpost. So I hope that gives you a little idea of where we're going and answers your question. So,
yes, right there.
Actually, your question got me thinking. What are they doing up there all day on the space station? You know, can you give us some idea of the average schedule? How long do they sleep? When do they eat? And what are they doing?
They have about an 8-hour sleep period. They have time both before and after sleep to do personal hygiene, breakfast, dinner, and things like that, spend time together, socialization. My daughter is an 11th grader. Right now she's doing the psychosocial, as a research project, the psychosocial aspects of deep space exploration, and that is one of the big things that our human research program is investigating. So they also have a lunch period in the middle of the day. Otherwise, they are doing maintenance of the station, which comes first. Again, the logistics associated with the resupply and the coming and goings of the crew, and then everything else is utilization, which consists of all of our areas of science like biology, physical science, space science, earth science, human research program, educational programs as well, and technology development. Those are our 6 research areas. Okay. You're welcome.
And can you pass the mic just right over there?
Hello. Well, something I love about the International Space Station is just the international part of it, how it's a global enterprise and it's all of our countries working together that have a space program to make something great. And so my question is, how do you guys decide how many astronauts from each country go up? And with this Demo-1 program and commercial crew program, once we're able to send our astronauts from the US as opposed to Russia or someplace else, will that change the amount of the number of astronauts from America that will go up, or will it stay the same?
I don't know the answer to your last question, but I can describe to you how the partnership is managed. It's a consortium of 14 different nations with about 5 nations that are the major partners associated with that, and that's NASA, Canada, the US, Canada, the Europeans, the Japanese, and the Russians. And so what happens is the way that the space station program works, and I'm not privy to all the protocols and all the agreements, but just as at a top level, is that each of the partners contributes certain things. It may be crew members, it may be launch vehicles. Like, as you know, the reason this is a huge change for us is we've been flying on Russian vehicles for a long time, and we've been resupplied by Russian Progress vehicles, cargo ships as well, in addition to the Cargo Dragon, in addition to the Northrop Grumman Cygnus. So those, it's been really cool to watch how the space program, since I joined it in 1989, has gone from just NASA to NASA and Russia with Mir, to NASA and all these international partners on space station, plus the commercial partners we're getting now. And it's just expanding, it's getting bigger and bigger, and it's just neat to see that. So to answer your original question, it's a partnership, and based upon contributions, sometimes they build modules, sometimes they bring in racks and facilities for research and things like that. That is how they do a barter system on how much of their research they do, how many of their crew members they fly, how many hours we spend on their particular items. So good question. I've never gotten that question before, but it's an excellent question about how we manage the way we use the space station.
Excellent, excellent. Let's thank Dave once again for presenting.
Thank you for having me.
Thank you. And our final presenter of the day is Mr. Steve Payne, who is the Launch Integration Manager for NASA's Commercial Crew Program. Let's go ahead and welcome Steve.
Thank you. All right, well, you've heard a lot about the launch vehicle. You've heard about the capsules. You learned about SpaceX and their operations. You've learned about the ground systems. You've learned about the space station part. There's one part that most people don't realize also happens, but it's the what if part. And it's associated with the soft, squishy things that we fly inside the spacecraft. All the mechanical systems have lots of redundancy built in. They have lots of emergency systems built in so that they can continue to work under almost any circumstance. When we get to the human part of it, it's a little bit different because these are human beings. They're not machines. They have to think under pressure. They have to be able to perform under pressure. We're putting them in a vehicle that is full, is 90% propellant, and it's a very high energy in a very small space. And we have flammable propellants, we have cryogenics, which are hundreds of degrees below zero. We have hypergolic propellants, which are highly toxic. They're at very high pressures. We have compressed gases, we have explosive charges, we have a whole variety of things. When everything goes well, like we saw, we make it to space, and we had a good day. Every now and again, you have a bad day when something doesn't go well. Benji mentioned, and I think you mentioned as well, we have what's in effect an ejection seat or a way to eject the capsule. If the rocket is misbehaving and we're having a bad day, you can use the escape system, and it'll pop the capsule off like a cork on a champagne bottle, plunk it down in the ocean a couple of miles offshore, and then we go pick them up. If for some reason that system is not an option because you activate it late in the countdown and you have to get away from the pad, then we have other ways to do that, to take care of the soft, squishy people that are up there. We have what we call our emergency egress system, and you've probably seen it back in shuttle days. We had it back in the Apollo days. And these are systems that'll get you from the tower, several hundred feet up in the air, to a safer spot about a quarter mile away, on long cables that are stretched from the top of the tower to the ground. And you escape down these escape systems. In fact, here's one test we did last summer out at Launch Complex 41. And we evacuated everybody from the top of the tower within a couple of minutes to a location a quarter mile away. Then we put them in armored vehicles, because we got all these great surplus armored vehicles, which carries them outside of an area we call the blast danger area. And that's where if the rocket were to do something really bad, the piece parts would fall in that big circle. And we take them outside of that big circle, where if they're injured, we have people who can sniff them for contaminants. We have people who can decontaminate them, hose them down with fire hoses. And we have medical teams that can treat them, stabilize them, and then eventually fly them off to the nearest hospital for whatever treatment they might need. We've exercised this several times. We had it in shuttle. We plan to have it for both our commercial partners. We're going to have it again for the Exploration Systems rocket for Orion. We're going to do that as well, so that whoever we send up on that tower has a way to get back down again safely. Failing to get themselves out, we also have a pad rescue capability where we can send trained firefighters up there to go grab them and snatch them and take them off the tower. So all of those are planned in advance. We also have, if they do an abort or they do an escape, they end up in the water, we have the Air Force is contributing parachute rescue jumpers, where they jump into the water near the capsule, they stabilize it, they put flotation collars on it, they extract the crew, they treat them, whatever first aid they might need, and they evacuate them by helicopter to the nearest hospital if need be. We also have, if we land on land, one of our partners is, their land landing is their default, although they can land on water. If we're out in the desert and we land, we have a medical team out there. We have a helicopter standing by that can take them to the nearest hospitals. We have a search team that can go find them. If we land in the wrong spot, our Department of Defense partners will also help us go out there and fish them out of wherever they might end up. So we're looking at all the different what-if scenarios, and if everything doesn't go right, what do you do? And that's one of the things I get to do. I used to do this back in the shuttle days for the shuttle program, and we've incorporated all that, plus all the lessons learned, into this commercial crew program as well. And here's a picture of our pararescue jumpers jumping out of their aircraft. If they land anywhere in the world in the water, we have a way to send aircraft down to them, send jumpers in, rescue them, get them out, and bring them back home. So it's essentially a full insurance policy all the way around the world if anything were to happen. Here's a picture of SpaceX recovery ship pulling up their mock-up. They have a mock-up they throw in the water. It doesn't get damaged if it gets salty. And I think our next one is their new recovery ship, which will pull up the capsule and has a helicopter pad on it. There's a medical team on board. There's a astronaut office team on board, and there's everything they need for post-mission processing. If need be, they'll throw them on the helipad, get the helicopters, and take them to dry land. Typically, they're just off the shore, or they're going to be just off the shore a few miles, and they steam in and bring the crew back that way on a typical day. So there's a little bit, that's the other part that most people don't see, that doesn't get glamorized and doesn't make it on TV, but that has to happen in order to make sure we're safe. At this point, I'll take questions if you got them.
Excellent. Right over there.
What is the thing you're most worried about on Saturday going wrong?
Well, this one doesn't have any crew. So this one's not too bad. My butterflies aren't going crazy on this one. For a normal launch, we have so many safeguards built in that if even the slightest thing goes wrong, it comes to a screeching halt and we don't go. And that's why occasionally you see that the launch gets scrubbed, because it's a lot better to be on the ground wishing you were flying than to be flying wishing you were on the ground. So that's not too much of a concern. We should be fine on this one. When we have people on board, that's when my worry beads come out, and I start worrying about, well, what about this? What if that were to happen? What if the other thing were to happen? So at every stage, there's a different risk, and we worry about whatever risks they're facing at that point. If they're there with a fueled rocket, well, I'm concerned about the fueled rocket. If they have to perform an emergency egress, well, then I'm concerned about keeping the fueled rocket from doing something unseemly. If they are injured, then I'm concerned about getting them the proper medical care. And all those different steps along the way, depending on what stage we are, that's where the concern is. Earlier, we had a question about health stabilization and quarantine. That's one of the other steps we take to make sure that the crew is safe. Starting 2 weeks prior, the entire crew is quarantined. All the people that deal with them are quarantined. And then some folks that have only casual contact have to wear masks and gloves and make sure that, and have all their shots to make sure that they don't pass any cooties to the astronauts before they go up to the space station. So.
Yeah, we'll get. Yeah.
This is a personal question, but I'm just curious if doing this as your life's work makes you really risk averse in your personal life.
Ask my family. Yeah, I overpack generally because I'm planning for what if this happens, what if that, here's my umbrella and here's my emergency kit and here's all this other kind. Yeah, I tend to do that, but I'm never caught short. And we tend to do that here. You've seen us in NASA, we pull rabbits out of hats often. But the only way you can do that is if you put a rabbit in there before the mission so that you can pull it out later. So all this planning that goes in are all the rabbits that we're hiding along the way so that when we need them, we got them.
And the gentleman over there.
Hello, Mike Marzano. Thanks for being with us today. My question is, it seems in the past with Mercury, Gemini, Apollo, and even SLS and SpaceX, we've used water landing as if it's more forgiving, and that Boeing is going to be using, they're going to be landing on land like the Soyuz does. What kind of factors does that come into play, and how do you feel about that? Because that's a first for an American way of landing, other than gliding on the shuttle or a water landing.
That's true. That's the first, but it's not the only. If you've looked at some of what Blue Origin is doing out west, their capsule also lands on land. So it's not unheard of. It's got its pros and cons, like we mentioned before. You need an isolated area, because if you're just a little off, you could land on somebody's roof, and that would be bad. Piece parts come off the rocket on its way down, so you don't want to be overpopulated area, so you don't do that. Because it's remote, it has its challenges, because we have to go way out in the middle of nowhere to go get them. You drive out in vehicles, it's got its pros and cons. On the other hand, if you land in water, you still got to go way out in the middle of nowhere, but now there's water everywhere, so it's all got to be in boats and in helicopters and other such things. Each has its challenges. We'll see in the long run, after we've done this enough, what's the better option. These spacecraft are supposed to be reusable. We're only going to use them once, but once they've been used, once they're refurbished, both our commercial partners can use them to carry paying passengers in the future. So they have great interest in making the spacecraft, making the turnaround between missions is minimal. If you put it in the water, you have issues with water intrusion and getting salt water on all your stuff, which has its own challenges. You put it in the desert, then you have dust and sand and miscellaneous other things that you have to go deal with, and it impacts a little harder. So we'll see after we get some runtime, which is the better approach. We got used to having a winged vehicle that would come down on a runway, and we'll probably see more of those in the future as well. So it's different ways to get there from here.
All right, and we have a question right here.
So you mentioned that the splashdown will take place a few miles, which you said, off the coast. How long of a ride is it going to be from splashdown to arriving back to Port Canaveral?
I believe it's about 24 miles. Within 24 miles of the coast is their target. This one's going to be a little longer because it's a first mission, and for tests you go a little longer. But once we get to human launches, they'll be within 24 miles, and that's a couple hours of steaming for their boat. So once they pick up the capsule, they get the crew out, they just start heading. Well, once they put it on the boat, while they're taking the crew out, they start heading back towards the coast, and they can be here within a couple of hours.
Is the crew removed from the capsule while it's still in the water, or do they pull it on board?
For SpaceX, their concept is to pull the entire capsule with crew on it, using their crane, and put it on top of the deck, and then you're standing on terra firma while you're taking them out. It's a little easier. Yeah. Okay.
Yes, in the back.
And there's one over here.
Hi, I was wondering if there is going to be a checklist in place. I started thinking of the emergency evacuations once the capsules are in orbit to check the bottom, like the ablative coding. Because I know that we didn't used to do that, and then after Columbia we did. So I didn't know if there was going to be a system in place where we check before we come home.
That's a very good question. Fortunately for these, they have a service module that's attached to the bottom which protects the heat shield underneath them. And the service module is going to be there the entire time that they're docked. So for Boeing and SpaceX, they each have their service module parked on the heat shield. Once they come back, they detach the service module, or the trunk in the case of SpaceX, just before orbital reentry. So they should have a pristine heat shield underneath it. And it keeps us from having to go inspect it.
And we have time for one last question.
This young lady's been trying to ask for a while.
Then let's get her the mic. Thank you again for your patience.
I can use this one. That works for me. So obviously you take precautions against this, but what happens if someone does get sick? Say someone has food poisoning right before a launch. Are you going to delay? And what do you do if someone's sick on the ISS?
Well, that's an excellent question. If they're sick on the ground, obviously we won't go. We have flight surgeons that are in the control rooms, and they're talking to the crew. And if anybody reports any kind of ill condition, we can come to a screeching halt. We'll give them a no-go today because somebody's iffy. We'll go inspect, make sure that that person is healthy, and if they're fine, we'll give them a clean bill of health and fly them another day. Up on station, if we have somebody sick, then it gets a little more interesting because you have to decide. You have to have the same number of spacecraft seats as you have people on board. So if you bring one sick person back, you got to bring 3, because the Soyuz capsules that we use right now to come and go have 3 seats on them. And if you bring the sick person back, you got to bring 2 other crew members with you. So that it's complex. We're going to have extra seats in these commercial crew vehicles, but that means you have to bring 4 people back. So it's a little iffy. It depends. They have medicines on board. They have flight surgeons on console in the control room who can handle most of the minor stuff. If it gets to where it's severe enough that this person really needs to come home, we'd bring them home, and we'd figure out how to reflow the mission accordingly. That sound like a good answer, Dave? Thanks.
Well, ladies and gentlemen, let's thank Steve for his time. And let's also thank the panelists once again for coming out and giving us some amazing information today. And again, if you have any questions at home, feel free to head to Twitter. #AskNASA is the place to ask those questions, and we might even be able to get to them at a later show. So please, please, please head on over there and do that. Thank you again for all of the NASA social participants. You've been wonderful, and thank you at home for watching, and we'll see you again soon.